Okay, we're going to look at the exponent laws. We're going to start with product of a power. So if you take a look here, we've got 3 sevens multiplied together, then 2 sevens, so in total there's 5. We can simplify that to 7 to the 5th, which means we add the 3 plus 2 together. So when multiplying powers of the same base, we add the exponents, but the base remains the same. You should remember that back from junior high. In terms of what it would look like in a general chart that you might see in a textbook, it's a to the m times a to the n. You add those together. And so for this example, bases are the same, copy out the base, and add the exponents here. Okay, so quotients of powers, so that's when you're dividing. So you've got 8 to the 7 divided by 8 cubed. What is that the long way? Well, that's another way of showing it. You can show it with the division symbol or with that fraction form. And then there's the long way. So think about when you're dividing, you can divide out common factors when you're simplifying fractions. So 3 of them divide out, and you're left with 4. So that's 8 to the 4. Well, how do you get 4 from 7 and 3? You subtract. So when dividing powers of the same base, you subtract the exponents, but the base remains the same. Okay, so the general rule, a to the m minus n. Then a specific example here, base is 6, so just copy whatever the base is, write it down first. Then look at the exponents, 12 minus 8 is 4. Okay? Try your best to make that smaller. If you're a big writer, then you've got to be careful. It's got to be really up high so you can tell the difference. Okay? Then power of a power. So this means, there'll be brackets here, this means there's 3 factors of 5 to the 4. So that's why there's 3 there. And what do those mean? That means there's 4 5s. 4 5s, 4 5s. Since we've already reviewed the product of powers, we can use that law. Add them all together. 4 plus 4 plus 4 is 12. How do you get that from this 4 and 3? You multiply. So that we added, that we subtracted, and this we divide. This we multiply. I don't know where I got divided. So add, subtract, and multiply. So we multiply the exponents, but the base remains the same. Okay, so the general rule is a to the mn. If you put 2 variables right next to each other, it means multiplication like that. So don't bother putting a multiplication sign, because then it might look like an x, and then that gets confusing too when we get into algebra. So here the base is 2, 5 times 3 is 15. Okay. Next one is just a variation on these other ones. Power of a product. So if you have 2 numbers multiplied together inside, then remember what a power means. That 3, that exponent means there's 3 factors of 4 times 2. So there's 3 brackets. This is the long way. We don't have to show it the long way. We're just doing it here. And so then if you look, if they're all multiplication, which they are, there's 3 4s multiplied together and 3 2s. So really what's happening here is the 3 is the exponent on both factors. Now this only works for factors. If there was an adding in between, then you can't do this. And you'll learn more about that in Math 10C. You would have to just evaluate, but that's more when you get into variables. In any case here, so we just go 4 to the exponent 3, 2 to the exponent 3. So when raising a product to an exponent, raise each factor in the product to the exponent, and then multiply the powers, because it might be a power inside as well. In any case, this is a to the m, b to the n. Okay, so this is 5 to the 4 times 2 to the 4. Once you get an exponent in there, you don't actually have to show a multiplication symbol. I'm going to use a dot rather than multiplication just to get used to that when we get into the variables. We don't want to use an X when we get into variables. So basically that power is applied to every factor inside the brackets. Similarly with the quotient, it's applied to every part of that quotient, every part of the fraction. So here, 2/5, the exponent 3, the brackets are around the whole thing. So that means we have 3 of them. So that really means we have 2 cubed in the numerator and 5 cubed in the denominator, right? So this 3 applies to both things. It basically applies to everything that's inside the brackets. So raise the numerator to the exponent and the denominator. Okay. So a to the m over b to the m. Okay. Then when it says divide the powers, you would just divide whatever value it had if you needed to. These we're all just keeping in power form. So 3 to the 5th over 4 to the 5th. Okay. You can evaluate it. We're just going to look at it like that for now. And the 0 exponent. So anytime you raise something to the exponent 0, there's a couple of ways of showing that. This is using patterns. So 2 to the 4th is 16. 2 cubed is 8. Because remember, this is 4 2's multiplied together. So notice as we decrease the exponent by 1, we're dividing the value by 2. So when we get down here, when we decrease 1 by 1, we get 0. And 2 divided by 2 is 1. So that's a way of showing that, and this could be any value. It could be 5 to the exponent 4, like a base of 5. It could be a base of -2, 1.3, any base. But if the base is raised to an exponent 0, the value is 1. As well, you can show that using division. If we have 3 to the exponent 4 over 3 to the exponent 4, well, using our quotient rule, that would be 3 to the exponent 0. But if we show this the long way, this is 3 times 3 times 3 times 3 over 3 times 3 times 3 times 3. And all of these 3's go into each other, right? So you're left with 1. Okay, and so this has a value of 1. So that's another way of showing it. The only way, if you have a 0 exponent that would be different from 1, is if you multiply it by something, okay, or add something to it. So if the exponent of a power is 0, then the value of the power is 1, as long as the base of the power is not 0. Yeah, so if you have 0 to the 0, it's kind of it's called an indeterminate form, and that would be the only exception. So this is going to be 1, this is going to be 1. Okay. All right, so let's use those to simplify some expressions. Turn over the page. Okay. Have it there. Just give me a sec. So it says right as a single power. So we don't have to even evaluate this. So take a look. Is the base the same? It is. It's in brackets. So keep it in brackets. Don't just get rid of the brackets. Okay, keep it. And then 4 plus 6 is 10. You do not have to evaluate. Next one, we're dividing. Write down that base. Always stays the same. And then what do you do with 12 and 10? Subtract. Exactly. So that's going to be 2. And then the next one, write down the base, the power of a power. What operation do you do for this? Multiplication. Exactly. So that's 12. Okay. Then in question 2, write 4 times 5 to the exponent 3 as a product of 2 powers. So again, you don't have to evaluate. You just have to show it as a product of 2 powers. So that's the one where the 3 goes onto the 4 and onto the 5. So 4 to the 3 times 5 to the 3. Okay. Same with the quotient, that 4 is applied to both the numerator and denominator. So that's going to be 2 to the 4 over 5 to the 4. Evaluating the next, there's a lot of 0 exponents. So remember, anything raised to the exponent 0 is 1 unless you multiply it by something. So this is going to be 1. This is also going to be 1. Okay. This is, that 0 applies to the 5. Okay. The negative out front makes it negative 1. Andre, can you split up your math? And then here, negative 1. So the brackets are around just the 5, not the negative. Here, there are no brackets, so that 0 only refers to the 5. If it referred to negative 5, there would be brackets. Okay, so that's why those ones become negative 1. All right, and then state whether each of the following is true or false. If it's false, write a correct statement where possible. So can you correct it to be to work out properly? So here, multiplying powers with the same base is 3 to the 15th, the right one. So thumbs up if it is. 3 to the 15th, the right. Okay, don't see any thumbs up. Nope, it's not. So that's good. So this is false. It should be 3 to the 8. Okay, we add the exponents. Next one, 2 cubed times 3 to the 5th. Can we simplify that to 6 to the 8? Look at the bases. Are the bases the same? No, so we can't add the exponents. What you could try to do is show this as 1 power, but because these are different exponents, we can't show it like this to anything, which is how you would get 6. So that can't be simplified. So it can't be simplified. You can evaluate it. Okay, but you can't actually simplify it like that. If you wanted it to be 6 to the 8, you'd actually have to make that 6 cubed times 6 to the 5th equals 6 to the 8. Okay, that's the only way to get 6 to the 8. Okay, what about C? Is that a thumbs up or thumbs down? Thumbs up. Okay, because this is like a 1 on 5. You don't have to show it, but it's understood to be a 1. So 1 plus 6 is 7. So that's true. This is false. Oops, sorry. So next one, kind of like this. This one, they multiplied 2 times 3 to get 6, but it didn't work with that exponent. So 5 times 4 is 20, but now the exponent hasn't changed. So if we look closely at this is kind of like working backwards from that power of a product. 5 cubed times 4 cubed. That's the same. So if we simplified within the brackets, that would be 20 cubed. So this actually is true. It's different from this one up here. Different because the exponent did not change. Okay, we just showed it, rearranged the equation. Okay, what about E? Thumbs up, thumbs down. Anyone? You all have thumbs? Thumbs up. Good, thank you. Thumbs up. 5 plus 8 is 13. So that's true. All right. on that front page, were there any laws that we summarized for adding powers? No. They were when you were multiplying powers of the same base, you added the exponent, but there are none when you were adding them. So this is false. Okay? Those looks like they added the exponents together, but you can only do that if it was multiplication. So you could change this. That would be an alternative, right? So this is false. Okay. Dividing here, thumbs up, thumbs down. 1 thumb up, 2 thumbs up, good. 3 thumbs up, yep, it is. Okay. Your dividing powers of the same base, so subtract the exponents. Okay, then a power of a power. Good, Jace. Okay. Now, 3 times 3 is 9. You have to multiply these. So students get a little bit mixed up on that. So this should be 5. If we have 5 cubed, that's 5 to the 9. So that's false. Okay. And last one. Thumbs up. Anyone else? Thumbs up. Good. Another one. Good. Another. Yep. It's 2 to, it's A to the 12. So this is correct. It's true. Power to power, you multiply the exponents. Okay, so then just question 6 here. It says write the numerator and denominator of that big expression in exponential form, and then write it as a single power. Okay, so looking at that, we've got some brackets, so I'm going to start by showing what each bracket is. So there's 1, 2, 3, 4, 5. So 7 to the 5th. 1, 2, 3, 4, 5, 6. 7 to the 6th. 1, 2, 3, so 7 cubed. Okay. Then write it as a single power. So you can take a look at it. All the bases are the same. They're all 7s. So you can do this all at once. Our base is going to be 7. We're multiplying. So 5 plus 6 is 11. We're dividing. So 11 minus 3 is 8. Okay, multiplying and dividing you can do all in one step. So that means you would add or subtract the exponents. Okay. Express each as a single power. So, got to think of order of operations. You always do brackets first and then exponents. Okay, before multiplying. So we've got brackets in here. I'm not going to evaluate these because it says to express as in a single power. It doesn't actually say find the value. So I'm going to then get rid of the brackets by taking the power of a power. So that's going to be 7 to the 16th. Although you can leave it in big brackets if you want. And then your next, that's going to be 4 times 10 is 40. And then your next, 0 times 4 is 0. So if you wanted to just get rid of that, you can, because it has a value of 1. And 1 times anything is itself. You can leave it there, though. And then your final answer, base of 7, but you're multiplying powers, so you add the exponents. So that's going to be 56. And same with the next one. We're dividing and multiplying there and then dividing. But we've got some brackets with a power of a power. So we've got to figure out what those are first. So that's going to be 3 to the 6 times 3 to the 8 over 3 to the 9. And then your final answer has a base of 3. Figure out what the exponents are. So multiplying, you add. 6 plus 8 is 14. Dividing, you subtract. So 14 to subtract 9 is 5. Okay? If you try to do some of these with your calculator and find the actual value, your calculator may even give you an error because the exponents will be too big. won't be able to do it. So you actually have to know these laws. And especially when we get into algebra, so ones that have variables, which will be next week. You've got to do all of this, but with variables, so your calculator can't do it for you either. Okay? And then 8, we're just filling in the boxes with the values that would make sense, make this equation true. So notice how we've got these two brackets with a base of 2 and this one with a base of 2. So we're going to compare those. We have this bracket with a base of 7 and this one. Well, that's it. If that's 7 to the 6th there, and this is an equation, this has to be 6. Okay? Equation has to be balanced. Remember, we talked about that earlier this year. Then now we have to figure out what this box has to be. Overall, this is 2 to the 20 times 2 to the box, and that has to equal 2 to the 28, right? If our equation is balanced. So if we're multiplying powers of the same base, you need to add the exponents. So that would have to be an 8. Oh, sorry, I pressed the wrong button there. Okay, so that we'd have 28 as our exponent. Okay, so I did power of a power, then I know those are multiplied together. That part has to equal this part. Okay. Next one has even more brackets. That whole quotient is equal to 2 to the 10 times 5 to the 4. So we kind of want to group them. There's the 5s, and there's the 2s. Okay, they're kind of grouped anyway. And so here, we figure out what this is so that we take the power of a power, we multiply those together, and subtract 5, because we're dividing to get 10. Okay? Well, that means, this will ask you, what number subtract 5 gives you 10? 15. So that means this has to be 15. So 15 divided by 3 is 5. Okay? Alright. Then these are powers of 5 multiplied together, so we have to add 5 and this box, then subtract 8 in order to get 4. Okay, so what subtract 8 gives you 4? So 12 has to be the total up here. So that you go 12 minus 8 is 4. So if this is 5, this has to be 7. Okay. All right, so last one. This is a thinker. So take a look at it. Calculator won't be able to give you a value. I think it'll say overload, something like that. So how do you think you can decide which one's bigger? One has a bigger base, but a smaller exponent than the other. Nathan? Yeah, so 3 to the 4. And then really we have to, if that's an exponent of 4, this exponent would have to be 111, so that when you multiply these together, you get 444. So that's the same as this one. If we split this up, that would be 4 cubed to the 111. So now, if these outside exponents are exactly the same, then we can just compare the inside, okay? Because if the exponent's the same, it's really which is the bigger base. So 3 to the 4, you can do that on your calculator if you're not sure, okay? And 4 cubed, I'll just put a comma in between them for now. So 3 to the 4th, if you do it on your, what's 3 to the 4th? 81. And 4 cubed? 64. So this is bigger than this because their outside exponents are the same. So now you can actually fill in with an inequality sign if you want. Okay? So which is larger? 3 to the 444. If basically in general, if the bases are pretty close to each other, then the larger the exponent is a fair bit larger than, well, actually, yeah. So if the bases are pretty close, the one with the exponent being larger will likely overall be larger, okay? If those bases are pretty close. Because as you've heard of exponential growth, things increase really quickly when you keep multiplying by itself, okay?